If we need to expand something like x plus 3 all in brackets squared, we can't distribute that square to just x and 3. Remember that square really means that it's everything in the brackets times everything in the brackets twice. So it's x plus 3 times x plus 3. To go forward, we would use our binomial distribution using our acronym FOIL to make sure that everything in the first brackets, each term, gets multiplied by each term in the second brackets. So x times x is x squared. O, the outside, x times 3 is 3x. I, the inside, 3 times x is 3x. And then L, the last terms in each bracket, 3 times 3 is 9. To then fully finish, we need to collect like terms, and we have x squared plus 6x plus 9. So the same thing happens here. Minus x, take away another x, is minus 2x's. So the whole point of today, looking at perfect square trinomials, is that's a perfect square because it's the same thing in each bracket times itself. We'll start to recognize a pattern that the O and I in FOIL are the same number, and it's just 2 of either one of them. To help us, we need to hopefully identify some of our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. Take a second, fill in as many as you can, which hopefully is all of them. If you can't, maybe you only know up to 12, maybe you only know up to 8. Luckily, having a calculator can help us. 256. But some that we should start to recognize or check in a calculator. So how does that help us? Perfect square trinomials is hopefully one that you can recognize. So this is when it's already been expanded and collected. So when we look at that first term, we want to see, is that a perfect square? So in this case, can I take the square root of x squared? Yes, it's x in brackets squared, or the square root of x squared is x. To get there, I'm going to square it. The last term, we also need it to be a perfect square. And in our standard form, this will usually be a number. So we want to see, is it one of the numbers above that we just filled in? So the square root of 9 is 3. Yes, so 9 can be written as 3 squared. Awesome. Now the next challenge is this middle term. We want to look, does this middle term fit the pattern that it is x times 3 times 2, because that would be the O and the I of FOIL, and be 2 of them. And if it fits that pattern, then we can right away go into our final answer of our perfect square there. So in this case, we would have x plus 3 all squared. So again, this is what we get if we were going forward. X times x is x squared. Our last term, 3 times 3 is 3 squared, which is 9. X times 3 and 3 times x is the same as 2 times x times 3. So we look and we see, does this fit the pattern? So this example right here, it does fit the pattern. So we would go right into our answer of x plus 3 all in brackets squared. So we do the same thing here. Let's see if it fits the pattern. If we can recognize it, we go right to our answer. If we can't, let's check. Can we take the square root of x squared? Yeah, that's x. Can we take the square root of 36? Yeah, that's 6. What's 6 times x times 2? x times 2 is 2x times 6 is 12x. Well, we got 12x, but the only problem is it's negative. So now that negative right there is going to mean that that's going to be a negative 6. So it fits our pattern. There's a negative. Because remember that really, the square root of 36, we could have positive 6 times positive 6 equals 36. But we could also have negative 6 times negative 6 to equal 36. That negative sign right there tells us that we're going to choose negative 6. So let's look here. Again, does it fit the pattern? Can we take the square root? Yes, the square root is x. Can we take the square root of the constant in the c position? Square root of 16? Yeah, that's 4. X times 4 is 4x times 2 is going to give us 8x. That's what we wanted. So we can use x and 4. That's the negative. So it's going to be x minus 4, all in brackets, squared. If we try it by decomposition, just to see that it works, the same sort of idea. I need two numbers that multiply to 49 times 1 and add to 14. That's going to be 7 and 7. So this would break down to 49x squared plus 7x plus 7x plus 1. Out of the first two, I can take out 7x. I'm going to have 7x plus 1. The second one, there is no common factor. If there is no common factor, I can still take out plus 1. Seven x divided by 1 is 7x. 1 divided by 1 is 1. What's in the brackets is the same. So I have 7x plus 1. What remains? 7x plus 1. What's in the brackets? Same in each bracket. So that can better be written as 7x plus 1, all in brackets, squared. A perfect square trinomial. If we looked at the above method, can we take the square root of 49x squared? Yes, that's 7x. Can we take the square root of 1? Yes, that's 1. 1 times 7x, 7x times 2 is 14x. This fits the pattern as a perfect square trinomial. So if we notice that, we can go right to our answer. If we didn't notice that, it still works by decomposition. All previous math still exists. So let's look at one or two examples to consolidate. Can we take the square root? 10x. Can we take the square root of 9? 3. 3 times 10x is 30x times 2 is 60x. Sweet, it fits the pattern. So my answer is a perfect square trinomial. 10x plus 3, all in brackets, squared. And I have fully factored. If I look here, and now I have an xy term, I have a y squared. The same thing can still apply. Can I take the square root of 9x squared? 3x. Can I take the square root of 16y squared? 4y. 3x times 4y is 12xy times 2 is 24xy. Awesome. So I have 3x and 4y all squared. That negative means that it's going to be negative 4y times negative 4y would give us 16y squared. So that negative just transfers to be a negative there. So for a perfect square trinomial, if A is a perfect square and B is a perfect square, then we can go right into the form a plus b squared, looking that the middle term is positive. If the middle term is negative, and a is a perfect square, and b is a perfect square, which is really in the C position. If it's a negative term, we can go right into a minus b all squared. Thinking that, again, this would give us our f, this would give us our L, and that would be O plus I. Same thing, that would be a times a is a squared. A times negative b and b times negative a is two of them. So that's our O and our I if we are going forward and expanding. Now the only thing that we need to see, it has to be a positive C value. So right there, that has to be a positive. It cannot be a negative because you cannot take the root of a negative number. Later on, that gives us other information about a parabola, but we cannot do that if the third term is negative. That's no good.